All right, good afternoon, everyone. Thanks for coming along, and thanks to all those who've been able to join us online with the unexpected bonus of an online talk that we weren't going to run except for the horrible weather that's come along today. So thanks very much for joining us. We're very privileged to have Dave Lawie, who's Chief Geoscientist and Technologist with MDEX, to come and give us a lecture today on the value of ore body knowledge and its relationship to copper and how ultimately it's going to be the driver for the clean energy transition. Dave's pretty well known around the geological community, particularly in the geochemistry community, where he is solely responsible for democratizing geochemistry through the production of biogas, which is a pretty amazing piece of software. And for any geophysicists in the audience, they need to produce something similar for geophysics, because the value of biogas and making the information accessible to users has been hugely influential to, myself and many other geologists who now routinely use advanced geochemical methods that without biogas would still be floundering in Excel and other horrendous software packages. So thanks very much to Dave for facilitating that. If anyone hasn't listened to that story, go listen to the Exploration Radio podcast. There is some offensive language that may or may not be used in that podcast, but it really is a great story that Dave tells about the origins of biogas and MDEX. So I'm going to pass over to Dave to give us a talk, and thanks very much, Dave, for taking the time.
Thanks. Oh, so I'm hearing myself. Anyway, it's a small technical problem. That's better. Right. I'll just assume the people online can still hear it. Thanks, Sean, and thanks for that very kind introduction. Anything that we can do to remove Excel from people's lives is a good thing. We haven't gotten to geophysics yet, but the next project for IMDEX to remove shit software. Oh, here we go already. Anyway, terrible software from people's lives is resource modeling, is block modeling and visualization. That's our next task on the list. So I'm here from IMDEX. Also got a couple of other IMDEX people here. James Cleverly, who's sitting there in the middle, who's over from the UK office, and Manu, who's just come up from San Francisco to have a listen as well. And then we're all going off to PDAC after this. This is a bit experimental, this talk. You'll see that some of the slides aren't perfectly presented. I actually listened to someone else give a talk yesterday on the airplane coming over from Perth and took a couple of pictures of my tablet on the airplane, and they're actually in the presentation. They don't look very pretty, but they do make a point when we have a look at them. It's also a bit of a hodgepodge of a topic there for the talk, but I think, or I hope, that by the time we get to the end of this talk, you'll see that all of these things are quite tightly related to each other. You're going to check if people can hear. Yeah, okay, all good. But just first, just a couple of things about IMDEX. We are a global business. I know a lot of you will know of us via iogas, but we do many more things than iogas. We operate with our technology across greenfields exploration, resource development, and mining. If you're looking for a point of differentiation for us, is we bring everything back into the digital space, and the internet has been a mission of ours for the past 10 years. We are everywhere where people are drilling and mining resources on the globe. So there's not many of us. Actually, there's only about 850 of us, but we are literally everywhere. And just before I get going, late last year, I was over in London at Mines and Money, and actually preparing a talk to give there at a workshop that James had organised. And just sitting in the hotel room in the morning before the talk, of course, getting it ready as usual. Nothing changes over 30 or 40 years. The TV was on, and this popped up. 1990, the British and French workers are digging and exposing the opening of the Channel Tunnel, the channel between France and Britain and England. And that is very significant in the history of IMDEX, because the navigational instrumentation, which was used for the last 100 meters of both sides of the tunnel to line them up properly, was a Reflex, which is a brand of ours instrument that was used to do that. So when that popped up before I gave the talk, I thought that was very interesting. Whole topic of a podcast, the history of this, because the Swedish guy who invented and built that technology went broke just before they lined up the tunnel. And at the time they did that, he'd had to sell the company to someone else just before they did it. But nevertheless, He was still credited with the invention and getting the job done, and was given a prize by the King of Sweden after that. But anyway, just little anecdotes. Now, I'm not really here to talk to you about IOGAS, but I must mention it, of course. And I assume that you all know that IOGAS version 8 is out. So if you're not using it, you must go and get it. There's only 2 things in it that I need to tell you about, which should cause you to get it. It has an undo button. It's right, the undo button, which people have been asking for about 15 years. Finally, it's in. But don't let me discourage you for asking us for things to go into IOGAS. Not everything takes 15 years. Some things are more complex than others. For example, we put a UMAP projection in a much shorter period of time than we took to put an undo button, but the UMAP projection is actually easier. And the other thing is the workflows. So honestly, 96% of anything you can do in IOGAS, you can save as a workflow and then just repeat it. So if you do the same thing twice in IOGAS, you should seriously think about turning that into a workflow so you don't need to go through that process again. It is incredibly, it's not just a macro recording system. It will actually record you selecting specific areas on graphs and things like that and labeling them. And it will even stop and let you ask a question. So it has 2 main uses. One is in an analytics type workflow where you get data in, you know exactly what you want to do and what you want to do to the data and get an answer out. The other thing you can do is use it to teach people. So you can build a workflow. So what should someone do when they open a lithogeochemical data set looking for alteration around a porphyry system? You could actually build a workflow which suggests that you should do this and this and this, clean your data up, open up this alteration diagram, circle out, so it plots. Something like that. So we know that quite a few people are using it in that mode. Anyway, that's enough about IOGAS. Now, just moving on a bit, just to talk about climate and resources and the value of information and the role we play in the world as geoscientists around these issues. Now here I've got a whole lot of stuff I've basically stolen and purloined out of other people's publications and talks, but I link them together in a way that people don't typically hear. And I do it in that way because people don't really understand anything much about this issue, despite what you read in newspapers and even things like The Economist and certainly on the TV. But just to get the ball rolling about climate, and when I talk about some of these things, remember I used to argue with geologists 20 years ago about climate change, because at that time I was most definitely in the minority in the geoscience world. And I used to get annoyed with my comrade geoscientists and accuse them that the only time you'll ever think that climate change is having an impact on the climate is when we're standing here waist deep in water just next to the ocean, which was previously the beach. And I found that profoundly depressing. But as time has moved on and as evidence builds that single weather events aren't climate, but as we're building up a series of these events and linking it together, and the mathematical models, et cetera, we get better and easier to use. I don't think anyone rationally doubts it anymore. And I think where the train really left the station was when the reinsurance industry and the capital markets decided it was having a massive impact on their future projections of profits and cash flow. When those guys work it out, then it doesn't actually matter what anyone else thinks, because that's where the money will go, right? That's absolutely where the money will go. It's also worth thinking about that. It also took the government out of the equation, right? So governments were obfuscationists, to say the least. A lot of them, not all of them, but certainly a lot of them. But even now, government's getting out of the way. And we've even got to the point now where the US is spending over $500 billion because they're now worried like shit about this, because they know that to fix this, we need a lot of things to be right, and they're not in the US's control at the moment. But a little bit about that, a little bit more about that later on. You know, carbon emissions, this I suppose it's not putting too fine a point on it, that this is actually an existential problem for the human race, right? To fix this, if we, right. And why might that be? I mean, you can just look at the increase in carbon emissions that have occurred since 1960, just since 1960. The other interesting thing on that plot, if you go back to 2000, and you subtract China, and China's incredibly rapid growth, it actually becomes pretty flat, right? Which is another interesting thing. There's, you'd all know the book Lies, Damn Lies and Statistics. data is just data until you look at it and you think about it. And so you could look at that and say, well, if China hadn't industrialized, then our path with CO2 would be, not as bad a problem as it is right now. But what right would we have to tell China that it can't industrialize, which generates a lot of CO2? Right? So there are levels and levels of politics in these discussions. And why has the level of CO2 emissions increased so much over that time? Because we use a shitload of everything. And we're using an increasing amount of a shitload of everything across the planet. Biomass construction and industrial minerals, oil and gas, of course, and metals. There is a shortage of sand in the world. Who would have thought it? There are companies now trying to sell sand to the Arabs for construction, right? Some of these things sound completely insane, but they are actually true. There are people exploring for sand in West Australia to sell to Asia for building purposes, right? So, the mining industry is more than copper, nickel, zinc, etc. We need to think about it in a very holistic way. Of that mining, and here I'm not actually talking about sand mining, but mining and mining extractive processes account for 11% of global energy use. Now, I heard a statistic like that actually when I was living here in Vancouver 20 years ago. I went to a brown bag talk, and I think back then it was something like 6%. I nearly fell out of my seat when I said that. But the current estimates are that it's 11%. That is a material amount. The other incredibly large generator of greenhouse gases is the making of cement, calcining to make cement. That uses about another 10% roughly of global energy use. So we're an actor in this game. We are a fundamental actor in a way causing the problem, but we are a super fundamental actor in helping fix it. And this is a message that I try and drum into people. I have 2 sons back in Perth. They're 23 and 21 years old. And of course, there's a lot of mining related people live in Perth. And I know a lot of them all got kids around my age or a bit younger. Our own kids in Perth don't understand the contribution of mining to the local economy, basically keeps Australia afloat and WA, let alone its role in providing materials for everything, right? Now, so living in a world where we need to talk to people about what the mining industry and geoscience needs to do to save the world is very difficult when they ran a survey in the US and asked kids, where does milk come from? And they said the supermarket. So if 95% of kids think that milk comes from the supermarket, try asking them where the copper comes from in their iPhone, right? They won't know. They won't have thought of that as a concept, right? Now, that's not their problem. That is our problem. We are an incredibly shit industry at communicating with the general public. Terrible, abysmal. If I see another sticker going around Perth that says everything is grown or mined, I'll just go, sorry, you're sacked. Whoever wrote that as a marketing message was probably a mining engineer or a geologist. It needs the proper attention and proper thought process put through a proper marketing people, Mad Men type agency, if you like, because certainly we're not getting the message out at the moment. We are spending more, or we're spending a lot more capital on renewables and renewable related technology. And if you look, so 2004, it's not that long ago for an old bastard like me, it's not that long ago. But if we get through to 2021, the numbers increased to over $700 billion annually now. That is a fraction of what we need to be spending. There's an Australian term for a very small number, or a couple of them. A bee's dick would be another way of expressing the small nature of that number. But see, this whole climate change thing and resources, it's always a good news, bad news story. But then you need to go back to the sheer magnitudes of things we're talking about. This is another plot, and this is of the global addition of electricity supply by technology. When you split it up by technology, if you look at that, you go right up to 2021, 75% is based on wind and solar of new capacity. So the world is reacting. It's trying to do something about it. There is absolutely no doubt, but it's still a drop in the ocean because there's not been enough of that new capacity added recently. And if we look at the state of the world and look at the billions and tons of oil equivalent and the contribution of the various forms of energy, wind, solar and hydro, and but there's that word again, is a bee's dick. It is not enough at the moment, despite the efforts we're currently putting in. And the particularly depressing thing there is it adds up to less than wood as a contributor of energy in the current system. So we have a ways to go, and we don't have very long to get there. This is the example of one of these slides. I actually took a photograph in the airplane yesterday, so I've not had a chance to pretty it up. But given that, planners and economists and government people are thinking about this, and this is just a graph I stole out of The Economist a little while ago, and it's a prediction of the source of installed electricity for the USA, just the USA, from about now out to 2050. And you can see there, and this is one of the scenarios, they call this a scenario of high electrification. And most people seem to think that if we're going to avoid this carbon problem, we're getting into a high electrification scenario. And solar and wind have to grow. I'm just trying to do the mental math there. It looks like an order of magnitude, if not times 20 or 30, in their ability to deliver the amount of electrification the US needs to decarbonize by 2050 or go carbon neutral by 2050. Now, that's a challenge with, sorry, what's that that's popped out? Look at that. The other thing here we can talk about is electric vehicles, and that graph there is a bit old, but we all know that electric vehicles have become, people become popular. People think that they're good because they're adding carbon to the atmosphere, they're environmentally sound, things like that. And quite apart from the energy budget, they do contribute some benefits like taking smog out of cities and things like that. There's no doubt, noise pollution, things like that. But just to electrify electric vehicles and the materials needed for those batteries, and you've seen some of these numbers in the past, I'm sure, but compared with the production in 2020, if you index production of these commodities back to there, then by 2040, that's not that far away. We'll need 42 times the amount of lithium, 25 times the amount of graphite, 21 cobalt, 19 nickel, and 7 times the amount of rare earths. Now, I only find that plot mildly disturbing, because when I look at those commodities, I go, lithium, no one's really looked for seriously ever, actually. And in fact, we can find new lithium mines we can bring into production. Because we haven't been looking for it particularly extensively, we're actually finding lots of lithium hard rock deposits at the surface in Australia. It's not one of these arguments that we need to be exploring at 1,000 meters depth and things like that to get it. And Australia's has upped its hard rock lithium production immensely, just in a matter of 2 or 3 years. We can respond, doesn't worry me at all. Same with graphite, right? No one's really seriously looked for graphite ever, right? We'll fix that one. Cobalt and the DRC, which you all know about, and the artisanal miners and the children mining cobalt. Yeah, that's an issue. Can we find 20 times more cobalt? Not a problem, geologically, right? Australia's full of it. There are massive cobaltian pyrite deposits sitting right at the surface all through the Kernamona block in Australia. Cobalt is now starting to be recovered as a byproduct of nickel laterite mining. There's already, cobalt was already just, within the last couple of weeks, swung into oversupply due to increased cobalt recovery from nickel laterite deposits. And rare earths, as we all know, aren't rare, right? It's just a matter of going out and seriously looking for them. We can find them. I do not look at that graph at all and think that is not solvable. No problem. What is a little bit of a problem, though, if you like your electric vehicles, is the input costs for those things are going up. So as we ramp up our ability to search, find, and extract them, they become rare, a bit rarish in the meantime, so the price goes up. So the price of inputs of those things into electric car has sort of doubled since 2018. So don't expect your EVs to sort of back off in price anytime soon. And all of those things are about double the inputs of what it takes to build a conventional car. And this graph is also a bit interesting. So this is the tons of CO2 per car when you take delivery of it and when you drive it. Okay, so the red line there is a diesel vehicle. The yellow line is an EV, a relatively small electric vehicle. So when the thing arrives on your doorstep, it's already responsible for 12 tons of CO2 in its construction, where your conventional vehicle's responsible for about 5, right? That's a small EV. Listening to someone else talk, most EVs, the bigger ones like the SUVs and things that are starting to come on the market now, the pickups, utes, whatever you want to call them, are more like 20 to 25 tons of CO2 are consumed in their production. Then you've got the CO2 that goes into them to make them run. Now that's a straightforward argument with diesel, but the slope on that line there for the EV, that is that is calculated from, good luck translating me, but yep, I'll just save that. Will that be all right? All right. That is a blended grid in Europe currently. So in Europe currently, not all of the power supplied on the grid is supplied by renewables, right? So there is still a mixture of coal and gas burning, oil burning to supply electricity. Hence, that line still goes up and to the right. What's a bit interesting is if you take the red dot and project it straight across, and all of the power supplied to your EV was provided by renewables, you've still got a lot of driving to do to get back in front with your CO2 usage, right? And that's not going to happen in any country anytime soon, most countries anytime soon. So these things are just worth, thinking about. Sometimes you just displace the problem somewhere else. And in fact, in Norway, where the uptake of electric vehicles is 70 or 80%, something like that, sort of been legislated that will be the case. Remember, they're using their oil and gas fund to pay for all that, right? So they're not getting it for free either. So, there's always stories behind stories when people talk to you about these issues. And I think it's really important to think about them, because some of the things you get told or you get caught up in arguments around a barbecue with are a bit simplistic, right? Moving a bit closer to copper now, coming out of some of those other commodities. And this is a plot I actually stole from Anglo American. And it's a good one, and it just illustrates the problems that have occurred with time now to extract copper for industrial use. And so back in 1900, to extract 40 kilograms of copper, we're dealing with much higher grade materials. So we only need 1 ton of ore at 4% copper to get the 40 kilograms. We also only had to mine 1 ton of waste to get at that 1 ton of ore. It took 3 cubic meters of water and 10 kilowatt hours of electricity. Well, now typically here today, to get that 40 kilograms of copper, we need 8 tons of ore because the grade is lower, the head grade's dropped in all of these mines. We need to move a lot more material. 24 tons of waste needs to be removed. We still use a bit of water, and because we've got to move all that material to get at it, the power usage has gone up 16 times. It is the extraction industry is an energy intensive industry, but we need the stuff to help save us from generating carbon. So it becomes, think this through, it becomes not an intractable problem, but it's a problem that needs the best minds on the planet to think through. Let's stick with copper for a little while. We've been mining copper since before recorded history. We've been looking for it and mining it since 1900. We've never stopped in the intervening period trying to find it and use it. In 2021, roughly, we used about 22, 23 million tons of copper, and a couple of million tons come from recycling. Now, if you look at that graph there and go out to even 2030, which is not far away, I might seem a bit further away, it's a bit younger, but actually it's not that far away. How on earth are we going to go from 22 million tons of copper to 30 million tons of copper per annum? Kamoa, the largest thing that's come online for a long time over in the DRC, is 500,000 tons a year. A Kamoa. We need 2 Kamoas a year for the next 10 years, 15 years to come online to supply the copper that we need to decarbonize. Lithiums, nickels, cobalts, graphites, manganese, rare earths, rah, whatever. Don't worry about it as a geoscientist. Copper, worry like shit about that, right? This is where the problem is going to come. There's world copper mine production from 1900 to 2010. Not really relevant to this talk, but it's split between electrowinning and solvent extraction and concentrates. But you can see it climbing up there. We actually need to change the angle on that graph. Do you know how hard that is to do in the copper world? It's almost impossible. And it's not just we need to supply more copper. If we take current projections of copper production, it actually falls in the next, not maybe next year, but the year after that. We could be in a 10 million ton per annum deficit sitting with what we have right now and just mining what we've got. Right. So we need to not only find new resources to bridge the gap from 22 to 30, 35 million tons, we need to find new stuff to keep the 22 million tons per annum going. Lots and lots of new stuff. Copper doesn't respond to price in any time rational manner. So there's a plot there of copper price in the green. I've actually pulled out a section there from 2006 to 2018 of the amount of copper production. You can see the price is bouncing around all over the place there, but the copper production barely moves. It's just steadily, trucks along, steadily going up, meeting the industrial requirements of copper. The lag is enormous. That's why the price and the production don't particularly correlate. Right? 2016, I'd argue with some big copper projects, 20 years sometimes before you can get something that you have found important and then get it into production. Here's another thing. Of those 22 million tons of copper, the 4 largest producers of it are Chile, Peru, Congo, and China. None of those countries you would call great exemplars of democratic governance and stability. In fact, a very long way from it. Chile is not having a great time politically at the moment. Peru is having a worse time politically. The Congo, God knows what will be happening there in 5 years' time. And China, well, China's China. If they feel like turning off the tap to work us over, they'll do that. They've demonstrated it. Absolutely, they'll do that whenever they feel like it. So of the current supply, apart from the geological problems of securing more supply and putting in production, the existing stuff we have is under threat. And this right now is a very, very finely balanced supply consumption equation. We can't stomach any rubbish going on in the copper supply chain, or it's all over, right? Our want and willingness to, if you go back to that graph from The Economist, to expand solar and wind electricity production in the US won't happen. It just won't happen. Some more graphs. I have some cheery things at the end of the talk with them, but I like talking to young people, especially students and postdocs, because why do I like to do that? Because it's your jobs to actually save the world, and I'm not joking. Right? It really, really is. Friedland said that geoscientists are gods as far as he's concerned, and he's bang on. He's absolutely correct. If you take the skills that are in this room away and elsewhere in the world and other universities are working, the world is fucked. And that will happen very, very quickly. Never forget that. Never, ever forget that. You're in the most important discipline, us and our mining engineering comrades, that exists on the planet right now if we're going to survive going forward. Now, other things here about copper grades, right? So one of the ways out of this, people say just mine more and more and more. Well, if you look at that graph there of cumulative production of copper and copper grade, you can see as we've accumulated more and more production from different types of deposits in different areas, the grade just keeps inexorably dropping. And this graph is reversed. You've got to keep reading the axes. And as the grade drops, the energy consumption goes exponentially up. So that's why there's actually a limit to the grade that we can mine using conventional equipment. Now, but if we're going to be running giant open cuts and 300 ton trucks and big comminution circuits, all the rest of it, 0.5%, 0.3% is still basically it. If you're going to mine something lower than that grade, then there possibly some in situ leach, for example, and the environmentalists would go slightly bananas about that. Is another technology being worked on, that company Jetty, about leaching sulfides, not copper carbonates. That's another interesting thing. But at the moment, they're still just playing around the fringes of this problem. They're not really getting their teeth into solving it. If you think that the industry is responding, and don't worry about all the details, I'll just tell you, again, I just cut that out of something yesterday on the aeroplane. But if you think the industry is responding by ramping up exploration budgets massively and getting to the coalface, so to speak, and getting to work, it sort of is, it sort of isn't, right? It's what we're doing is within the realms of what our industry conventionally does in the face of these things, which is not much, actually, because everyone's still risk averse. And if you look at that graph on the right there, don't try and read the thing there, but what that's telling you is that most of the exploration activity is still dominated by gold. Now, gold exploration and mining is fine. When I left university, I did not want to work for a gold company, because I wanted to work for a company that actually found things that were useful, things that you build things with and help people, right? I didn't want to work for a company that dug it up and put it straight back under the ground. But just as a reflection of our industry, typically half, maybe a bit over half the total global exploration expenditure still is spent on gold. Next would be copper. And the amount of exploration spending on copper is increasing, but nothing to write home about, right? It is increasing, but not really anything that's going to make a difference to anything, actually. It's a bit depressing. And then there's, apart from exploration, there's mining capex. So the existing mines need, I told you that the production of copper was going to steadily start falling if we did nothing with our existing mines. To extract more copper from them, they need a lot of capital expenditure spent on them. And that is the capital expenditure by commodity since 2009. Our industry has left the fucking party. Right? It hasn't got the memo. The bottle's rolled up and they haven't pulled the cork out and pulled the message out of it yet. I find it unbelievably frustrating. A message I often taken talking to my mining industry comrades is, I don't think you've got it in you to do it. I just wonder if our industry can actually do anything about this. I honestly don't think it can. But I'll come back to that. There's the predicted capital expenditure, which these guys think needs to go into mining to do something about increasing capacity. But to moderate that comment a little bit, it is not just about spending the money, it's getting the government permits to spend the money, right? So, for example, Anglo down at Los Bronces in Chile is trying to spend a lot of money to increase copper production there, but having terrible problems with the government down there doing it as well. The more political problems you have in jurisdictions, the less likely you are to want to go out and spend $10 billion of capex, which you need 5 or 10 years to get back as well. So a lot of these things become interlinked. There's total copper inventories. This is all about economics as well, in a way, but there's only the one trend line there of total copper inventories is down. Here's our major copper discoveries, and Sean and Craig would have, I'm sure, spoken about this over the years to students and in people that work with the MDRU. As an industry, we've got to fess up to something, and that is that we haven't actually been very good at it for the last 10 years at finding many new copper resources. We really haven't. And that's also an issue. This is, when you read commentaries, even people that purport to understand mining, and they talk about securing an increasing supply of resources in the face of decarbonisation, the bit they don't get is exploration, right? They think that we will spend this money and copper will appear 16 years later. But that 16 years later, time zero starts after you've found something. It's not the work that goes up to T0, right? That is not included in those numbers. So there's a lot of education needs to be done. Starts with you guys around the barbecue, talking to your friends. If you've got kids, talking to your kids, talking to your kids' teachers. That's where these discussions need to really be had. There's another thing going on. I'll try and stop depressing it a little while. We'll get to talk to something else, but balkanization of supply chains. So where are these things? So I was talking about copper before, being Peru, DRC, Chile, China. This is an interesting bit of work, which it's not mine, I've taken someone else, but I've conflated a couple of different things and put them together here. That map is colored in by countries who did or did not vote to censure Russia after the initial invasion of Ukraine. They either didn't vote against it or abstained. And the world just colored in by that. It's an interesting map. It really is a very, very interesting geopolitical map. I was in Africa 3 weeks ago, and there was an article in the newspaper there that the Africans were running war training exercises with the Russians and Chinese, right? Interesting. Why is that, you might wonder? Not everyone shares our view about the Russians going into Ukraine by any means. I'm assuming you have the other view, but anyway, whatever. But if you take the resources between the red and the white groups there, if you look at global oil reserves, actually dominated by China and Russia. If you look at global gas reserves, dominated by China and Russia. If you look at ferrous and metalliferous reserves and resources, things get very, very interesting. So copper, US aligned, but then we have Chile and Peru, right, who aren't exactly stable democracies to start with. PGMs, so if Russia ever decide to do, if the Africa ever decide to do something really crazy and completely align themselves with the Russia-Chinese trading bloc, there goes the PGMs and your catalytic converters and what you need in hydrogen cells as well. You can just kiss goodbye to it, right? Cobalt, some of these things I'm less worried about. But when I saw that, I thought, man, this is during tail end of COVID as well, but I can look at that and I can see a good reason for a good old bust up and Barney globally about these things. Once these messages I'm talking to you start to sink in further and further and further into governments, and therefore the populations, people will start to worry more about it, about where it comes from, then their mind will go to the geopolitics of it. It's this stuff that's driving the US government now with their $700 billion investment in critical infrastructure and decarbonisation. They're trying to relocate as many supply chains as they can for these materials into the United States as fast as possible. And you know what? Americans being Americans, they're doing it, and they are actually doing it at speed. They're not just talking about it. I know 2 Australian companies who are going to build a manganese and a lithium plant in Perth, and they're just about to sign the things. They're both whipped off over to the USA, now building them in Louisiana, just because the US government waved a whole lot of cash at them and de-risked the projects for them. So things are happening. I'll skip over that one. That's too depressing as well. Now, just some commentary in the media. So things you'll hear. This little quote here I took out of the Australian Financial Review. It's a very reputable financial newspaper in Australia. But I hate it. I read it and I just about screwed the thing up and threw it against the wall. Going on about copper supply, some expert talking about copper supply. And if you just look at the red box, we expect to see large deficits over the next 10 years because there is not enough supply. Okay. But even less given the current copper price. To meet demand, which should lead to a higher equilibrium copper price to rebalance the market. We're just going to put the price up and magically copper will be found. Now, it's so idiotic, it beggars belief. It was one of those, grumpy old man yelling at the sky moments. So I thought, I'll write a letter to the editor. I didn't. When I'm retired, I'll do that sort of stuff and torture them. But that is an example of the thinking that's going on in the general public, right? But this is the educated general public reading financial newspapers. They don't get it. They don't fucking understand. Here's another one. This was actually written by a copper task force talking about the problems with, I think, the copper something or other group in Australia, who write about it strategically. And they had this, it was just like a McKinsey report or something like that. And then it was solutions. And what will we do? 8.1 in the report, discovering how we're going to fix it. We're going to take advanced technology and we're going to go and do this and just do it. And you just, again, this is another one. You read it and just get infuriated. They have these people just have no cognizance of the difficulty of the task involved. This is for you. You're going to have to deal with these people in your careers, right? You are going to have to bat them back, put them in their place, and inform them of facts, and try not. Yeah, just a little bit about the value of information I want to touch on, because in a way, the value of information is an important part of this discussion. As geoscientists, we have, and in fact, we're just talking about this, Sean, in a different sort of aspect of it. But if someone asks you about geoscience, Sean was saying what we want to talk about is the latest natural disaster that happened in the world somewhere. So it's just not a good way to engage the world about geoscience. And it's interesting, yes, but is it going to draw them into the conversation? No. The other thing about geoscientists is we typically hate not numbers, but dollar numbers. We find it very difficult to articulate the value of what we do in dollars. And this holds us back. It will hold you back personally. I'll tell you in a company, if you can't do it, it holds companies like us up, IMDEX, trying to develop technology if we can't articulate the value in dollars. It holds up the people in resource companies that we deal with. If they can't articulate the value of what they're doing in dollars to their boss, it holds up the entire geoscience exploration groups in these big companies if they can't properly articulate the value they deliver to their parent company. It holds us all up. So we need to get better at expressing the value of what we're doing in dollars. Right? We just need to get better at this. Now, I'm doing some work with Mike Samus on this, who's over in Toronto. I'm going to see him next week over there. But also, this fits into another project which we had a go at starting here called the Value of Information. But working with Sean and with John Steen, we're going to put in an NSERC grant to get that project amped up properly, and maybe even IDN Technology as well, another local technology company. So if there are any people here close to finishing the end of the degree and you like this sort of discussion, this is the sort of thing that this project will work on, putting dollar values on all of these concepts. Now, this is something that, and Mike Samus is a mining engineer and a financial guy. I just call him the quant for short. He's a very, very smart man. But this is his words for describing what the exploration process is. And it's actually pretty good, I thought. We need to test ideas. We need to test assumptions, prove whether they're valid or invalid as quickly and cheaply as possible. Quickly and cheaply as possible, but not too cheap, right? Got to do the right thing at the right time. I added the bit at the end there, using the best available technology. Often you can't use the best available technology on a program because you can't articulate the value of it to your boss, because it costs. Exploration is always a cost center. So all you're asking for is another cost. Then the exploration boss probably turns around and goes, I could drill another hole for that. How are you going to answer that question? So if I can drill 10 holes and pick up this additional information to make a much more reliable decision, is that a better thing to do than to drill the 11th hole? So we'll be working on tools to equip you to give a financial number to aid that understanding. Now, this gets pretty complex, and I'm not going to go into it. It's a work in progress. But if you look at the value driver tree over on the right-hand side in the red box, Mike's sketched it out. So you run an exploration program. Time is on the base. This is the other thing here. Time is money. You've all heard that, time is money. Often in exploration, we completely forget, actually, that time is money. We're working with another big company on a big drill out in Africa, and they tell us that if we can help them, every year we help them shorten the drill program, add $700 million in NPV to the project, purely because you bring the money generating phase closer. So if it's going to take you 10 years to get into revenue generation, those numbers you're going to generate in 10 years are discounted by inflation. Right? If you bring them forward, they're less discounted by inflation. Now that we're back to a high inflationary environment, people are going to be thinking about these things again, right? So these are concepts that will kick around. So we run exploration, we receive some information, we either decide that there's something there or not. Now we run the possibility there of making a true negative decision or a false negative. We mistakenly assume there was nothing there, walk away, or we properly tested the ground and there was nothing there, we walked away. We're still confident going, we go on, we spend more money, we get the thing into development, and we generate additional data, and the thing was there, it was what we thought it was. It's a true positive, everything's great. Or we get into production and then we find out we did not know a whole lot of stuff about it, and actually it's a disaster and we've done our dough. Right. These are all arguments for all body knowledge, rock knowledge, whatever you want to call it. Rock knowledge, all body knowledge is information. What's the value of that information? What's the value of that information at those different nodes on that diagram to increase the reliabilities of the decisions you're making? Because you can attach dollar figures to those. It's complex. It's not just it's a Bayesian statistical approach. And it's not just one minus the other or anything like that. It's complex, but it is possible. So just to give you some ways of thinking about true positives, false positives, true negatives, false positives, sorry. So true positives, you drill a hole into something, you get very positive indications in early exploration drilling. You drill through the mother lode, so to speak. You use things like hard rock seismic, maybe even the muon thing that they have that give you a very, very strong indication something there, and it's true, it's fine. False positives, when you're putting things into a model, you may have actually found something, but the mineralization is refractory, it's too hard, it contains shit you don't want in the mill. You've under-drilled it, you didn't properly or correctly describe its geometry. If it's an underground mine, that can be an absolute disaster and send you broke. You have a resource reserve conversion issue. So once you get in there, you can't convert those resources into minor reserves for whatever reason. There's plenty of them. False negatives, the thing that completely and utterly freaks out geologists, that you walk away, but there's something there. Near miss, you made wrong assumptions about the target you were testing. You had shit quality data. You were running a type of, and I put in MMI there from source sampling just to put it in. But it generated, you thought that it was what you thought the method that you use would detect what was there if it was there. Is that true? How reliable is that? So that can also generate false negatives. And then true negatives. This is truly, in most exploration geoscientists' lives, the most economically important decision we make is to walk away. Because remember, and this again, time is money. If you make the correct decision to walk away as early as possible, it gets you onto the next project, which from there you may have a success. If you piss around with something that's found and it's never going to make it, then that could consume 5 or 10 years of your life where you could have been looking for another 2 or 3 things. Right? So it's all a bit of a numbers game when it comes to that. But it is most definitely the hardest decision to make. I'll go over that one. And just to back up, just to give you some numbers around those false positives when you get into production. This is where the value of information work started a little while ago, working with John and Michael and Andrew Gillies, who was a student here as well. So Andrew actually went over TSX and then latterly ASX press releases and looked for impairments and what was the cause of the impairment. So impairments in stock prices, the company comes out, announced they balled something up and they lost an incredible amount of money on the stock market. And this is interesting. So I was talking to John, I said, well, how many of them were related to geoscience, rock knowledge, ore body knowledge type issues? And fully one third of those announced impairments were because they didn't collect the right information early enough at the right time. It's a value of information argument. If you had the right information at the right time, you could avoided a third of those impairments on the stock market. So we're not talking about nickels and dimes here. We're talking the tens, hundreds, if not low billions of dollars when we're talking about these issues. These are big, big conversations. Ore body knowledge is also useful in another way, and this is a paper written by Rick Valenta over at the SMI at the University of Queensland. He wrote it a while ago now, but it's really good. And really what that's a table of is a table of stranded copper assets. So these are things that are actually found, but we can't mine for one reason or another. And the reasons are given across the top there. He subdivided them up and gave them a level of importance. So stranded copper assets. So what new information could we go back to these stranded assets and prosecute them with and unstrand them, right? There are some easy copper supply wins in amongst these, not all of them by any means. If there are water problems and community problems, government problems, political problems, things like that. You're not going to solve them with ore body knowledge. That's a completely different skill. But some of them are limited by those things. In fact, interestingly, looking down the list, some of these things have already been pushed along and into production, unstranded for like. So Quellaveco, Anglo picked that up. And in fact, I think it goes into production almost about now, I think. Los Bronces underground, well, they're desperately trying to do that, but get held up by the government. Barrick has gone back into Reko Diq on the border with Pakistan and Afghanistan. That tells you something, actually, that some people, the risk appetite for getting into these projects, given this looming copper deficit, is true for some companies. They're really making the effort. That is a giant deposit. If that can be unstranded, given its geopolitical complexity, that would be a big win for our copper supply of the future. And then you've got Kamoa, which has actually come into production now, providing 500,000 tons of copper. So there are a few different ways of looking at the copper supply problem. Right? We don't necessarily need to find everything from a greenfields exploration startup. Now, what are some things that confound us as geos? I'm just going to quickly whip this through this. The value of information. So, I mean, talk about numbers and trying to think things through, but geologists are very visual thinkers. It's hardwired into humans, but geologists are particularly susceptible to it. We see patterns in data, which what we're trained to do, and often act on them without thinking it through too much. That picture there is was on the front of a data analytics book, actually. But it was just making the point that we've evolved to see things. So we've evolved to see threats around us. So the tiger in the grass, right? We don't need to look at that, analyze it and go, shit, there's a tiger there, we better run. That's all happened before you've had that thought, you're already running, right? So this is our bias when we look at things, to jump straight to conclusions and go straight to interpretive mode. So what does that mean? We look at patterns and often mix up cause and effect and complete bollocks. And this is a problem, right? Because talking about every time we get sucked in by this stuff, it costs us time, right? It takes us further away from making that decision that there's nothing fucking there and move on and do something else. So these are things that have been published over the years. I don't try and pick on people, but some of them just bollocks. This story is a line of soil samples, and come on, saying that can see this flat ore body at 300 meters, looking at a moly and uranium response with very, very widely spaced samples, a single line. It doesn't even go very far past the edges of the ore body. You know, that's just beginner's problem. But we can do things in our work. So using geochemistry as well. So that was a shit signal. I was just rubbish. But we can design our sampling programs, whatever they are, geophysical surveys, where we can, if we design them properly, we get the chance to amplify the signals that we're looking for, to make it less ambiguous, to make sure we make that initial judgment correctly. And things like this. So if you don't understand the processes, so I always, you know, people just ask me, just going back to putting my geochemist hat back on, tell me a plan to do something. So you can't have a plan or a cookie cutter plan if you don't understand the physiochemical processes that are happening where you're working, right? Now there are some parts of the world where you go and take a coarse fraction soil sample to detect gold. There are absolutely some parts of the world that do that. But if you blindly took that practice and applied it in this terrain, you would absolutely miss the target, right? Because the gold doesn't report into the coarse fraction. The gold here reports into the fine fraction. So you can guarantee in that part of the ground, people would have gone over that multiple times, sieving out the gold anomaly, then sending the coarse fraction off to the lab. Now, you can go somewhere else and the coarse fraction has the gold, right? So you've just got to understand the processes that are going on in your area. Some of you will have seen this before, but stream sediments are unbelievably effective geochemical prospecting technique. But you just need to think about the size of the catchment. And that's just a model. I mean, it's just a simple bit of maths, but, you know, Chuquicamata, giant copper deposit before it was mined, it's you know, rumored that the size of the anomaly above it was 1/3 kilometers and at least 2,000 ppm copper. Now, if you assume everything's equal and you degrade that catchment into a stream sediment, you can dilute the signal to 100 ppm at a 10 square kilometer, in a 10 square kilometer catchment, if you go and pick up that stream sediment sample. 50 square kilometer catchments, and boy, I've had lots of arguments with exploration managers about the size of catchments for stream sediment sampling. And that's why I made this graph. And I said, well, mate, if you want to miss Chucky Kamada, go for your life, but I'm not going to be a part of that program. Right? So again, it's worth thinking through the processes. If you're going to compromise the outcome of what you're doing, don't do it, because all you'll leave is you'll have an incomplete data set from which to make your decision. And even though it's incomplete, you will be forced to make a call on it. Always remember that. At some point, you're going to have to make a call. This one, some of you will have seen as well. So the tiger in the grass thing. So, you know, a grid of data. Everyone likes to grid official data up. You put lines on the map. Everyone knows when you put lines on a map, they're factual and you can't change them. But that's random data. That is actually, I went into Excel, I made up some random numbers and I put some coordinates against it and I gridded it in gas, and that's what it looks like. But, you know, if you look at that and look at that, you'll convince yourself that those things exist in that image, but they don't. It's complete and utter bollocks. So you got to be careful. And again, this is a design thing. You know, don't make things hard for yourselves. So that's a variogram up the top, and you're probably not resource geos, but resource geos use variograms all the time. Applies to surface sampling as well. So if you have a high nugget, so if the variation in what you're collecting that is very high, just from sample station to sample station to sample station, you've got a high nugget, you're not going to resolve out any regional trends or see any anomalies, because it'll be hidden in the variance of just the the local, the short scale variance. You need a variogram that looks like that over on the right. So very small sill, and then you can map out properly the patterns and the things that you're measuring as you cross over the terrain. That's not actually a geological example. That's a signal analysis example from electrical engineering, but it is exactly the same concept. And just going back to the tiger in the grass, when I was working for Pasmingo Exploration many years ago, the guys who flew the airborne gravity gradiometry, the Falcon thing, before it was owned by Fugro, came into us and tried to convince Pasmingo that we should pay them a shitload of money to fly that thing on our leases, and perhaps even go into joint venture with them on the leases. And they were showing that as an absolute laydown misere, as it was 100% likelihood detector of a Cannington ore body. We weren't very impressed at Pasmingo when we looked at this. And eventually we got a bit sick of them. And I said, look, if the Cannington ore deposit wasn't wrapped around an amphibolite, would you still have that gravity anomaly? And that they could not answer. Right. So you take the amphibolite out from the mineralization, I don't think there's just anything there. But I challenge anyone to look at that and go, yeah, there's a very large lead, zinc, silver ore deposit in there. Thinking, and I'll go over that one's a bit too complex. So just a little bit about how we quantify some of these numbers. This is a real example that Mike worked on. It was some published numbers which he went through. So the present value of this thing that was reported by Seabridge had a development capital of 5 billion, NPV of operating profits of 9 billion, so roughly 4 billion in NPV once you subtract one from the other. He ascribed a development of probability of success, one of the nodes in that diagram, about 50%. So the NPV value is about half the 4, so it's about $2 billion, right? So let's say we had a program there to go in there and fully define it. We know it's there now, so it's a bit of backwards engineering. That we went on for 7 years, it cost $300 million. And we gave those false positive, false negatives a quantitative conditional probability of being correct or incorrect. So 20% conditional probability of being incorrect, we get imperfect knowledge. We can actually measure the value of that on the NPV of that project when it's at this 50% chance of development phase. And without looking at too much detail, there's the 2 billion. And then we need to subtract from that the time. So I'll go into this. So the cost of the program, 300. Here are the costs for having poor information. The conditional probabilities have a cost of 300 and $250 million, right? These are the chances of making missteps along the way. And the other thing here, which people often don't think about, is the cost of delays. So you start drilling, you come into production 7 years later, that has a cost on the net present value also of $890 million. So delaying things and then doing a bad job adds up in cost until you've almost got zero value in that project when you take these probabilities into account. Then I asked Mike to rerun it. And I said, well, let's say that We're going to redesign the program. And there are many ways of doing this. Directional drilling, for example, one parent hole directional drilling off the top, optimizing the drilling in a better way, doing some more geophysics before we start drilling, all sorts of things like that. But we're going to reduce the drill program from 5 to 7 years. And we're going to reduce the false positive and negative rates using the conditional probability to 10%, right, rather than 20%. But we're not saying that comes from free, because that extra information is going to cost us 100 million, right? So the drill program goes from 300 million up to 400 million. So there is a cost to it. What is the effect on that? The effect on that, they're the old numbers that head down there. So after we're doing it the old way, is $400 million. By just shortening the program by 2 years, we get $207 million back. We spend 100 getting more information, but of that 100 we get back 250. So it's about $125 million in value at that stage of the project by improving the conditional probabilities in our favor of all those decisions that go on the way through. Now, this is hypothetical. It's not that hypothetical, actually. But again, if you're interested in this stuff and we can get this NSERC funding, and it takes a particular type of brain to be interested in this sort of thing, I will admit. But these are the things we want to take into the real world and run multiple scenarios with it. So you can answer the question. I want to, let's say I want to do a hard rock seismic program before I start the brownfields drilling. Boss goes, that's $6 million. I say, well, but it's going to provide $150 million benefit in 3 years' time. So it's nothing, it's cheap. Why wouldn't you do it? Right? Something like that. I'm going to collect more mineralogy data, right? I'm going to collect fluid inclusion data and do whatever it is to help you make those decisions. So a talk like this isn't complete without talking about ChatGPT. Like everyone else, I've had a play with it. I actually used this cartoon for something entirely different, but I actually looked at it and went, man, that is a summation of ChatGPT. It is entirely possible that it can give you plausible nonsense. So always remember that. But man, I do see a day where this actually helps us in our exploration programs. Not here yet by any means, but it will get here. I heard an economist call it the greatest deflationary event in a lifetime in the global economy. And if any of you are familiar with the Hitchhiker's Guide to the Galaxy, the telephone sanitizers are done for. It's another way of thinking about it. Who's online? Some other things here to finish on a more positive note. And I think this is a great quote. I was listening to Tony O'Neill. He's retired now, but he was Anglo American's technical director. And someone just asked him in a question in the meeting, and he just riffed that off the top of his head when he was talking to someone. And I frantically wrote it down because actually it's one of the most sensible things I've ever heard come out of a mining executive's mouth. It is just perfect. And whose job is it to get society to that point? It's our job, right? No one else's job. We are the only group, and mining professionals, we're the only group that can get there. Some other things just to think about. This is something I took out of The Economist, I think. And this, I read this and I had to copy it because it was just so outrageous. They're talking about the North Sea, the shallow North Sea, just next to 9 European countries. They have plans to install 260 gigawatts of offshore wind power by 2050. Nearly 5 times that produced worldwide today, enough to power 200 million European homes. You read that and it's just gobsmacking. But where's the copper? It's I read these things and I get very excited about that. But I go, where's the copper? The rest is fine. We'll fix it up. They might not want wind farms all the way around the Northern European coast either. Different thing. Another brave new world thing. So how can we speed up and increase exploration success? And you guys will have heard of cobalt metals, which Bill Gates is an investor of as well. You can read all the junk along there. They're actually an AI-driven exploration company that does exploration, actually peg leases and things like that, makes it a bit different. But the Brave New World thing there is right at the end there. 2/3 of our team are software engineers and data scientists who have never worked a day of exploration in their life. The other third are actually experienced explorers. Now, I could ask the time, is this the future? Will this work? I'd love to be proven wrong, but I don't think so. Actually, that's my thought at the moment. I don't know, but I'm so glad someone's having a crack with a different approach, because it's a bit like sources of renewable energy. Not one will be it. Every last thing the human race can dream up of in the next, 10, 20, 30 years will be required. And I think with exploration approaches, there's not going to be one thing that solves it either. Every last thing that we can think of will have to be tried. So good on them, right? Good on them. I'm actually going to have a chat to them at PDAC. And for your barbecue chats and talking to your kids and your kids' teachers and things like that, this is an interesting quote. It's known, but it gives it context, right? So mining disturbs 1% of the land area that broadacre agriculture does. 1%. Now, you could get in a really good argument, not that I want you to, around what are the impacts of broadacre agriculture on the ecosystem and the environment, etc. But just remember that 1%. Where do you want that 1%? So if the NIMBYs come to you, well, have you got a farm over that side? You can have a mine on that side. Right? 1% doesn't include forestry, doesn't include cities, all that sort of thing. Just broadacre agriculture. And just a final thing here to blow your mind. The mining industry has an immense task, like a super immense task to do, but it's tiny. Reading the end of that, again, it's one of those things you read and you go, what the hell? Talking about Apple's value. So Apple, you could use the value of Apple to buy the world's 50 most valuable mining companies. The next 50 still have enough left over to snap up 3 years supply of global mine production, 60 million tons of copper, and buy 2022 seaborne iron ore, just to throw it in, right? Just a few things at the end there. This is a problem because the industry is not big enough to address this. In some of my wilder moments talking to my industry colleagues, I tell them that what's going to happen to them is that big oil, BP, Exxon, Shell, is going to come over and take this industry over. Thank goodness, because they have the scale to affect some of these changes. I have another saying for our industry at the moment, and that is, it can't read its label from inside the bottle. And on the outside of the bottle, it says save the world, but you cannot fucking read it at the moment. It's a problem. So I implore you guys to go on with the job, because it's your job now. There'll be old bastards like myself be handing over the batons now, and it needs, we need the best and brightest minds on the planet focused on this problem. And that is the exact opposite of what's going on globally in mining and geoscience at the moment. Not just to do our jobs, but to educate the entire world around why our jobs are absolutely important for the future of the planet. It's a good message. You pick it up, start talking to people about it. Every person you tell, they'll tell someone else. Just tell them the 1% story. That's enough. Next time it comes on the news, I go, yeah, really? Only 1%? Why can't we look at that? Even Sweden's coming around to mining. Even the general population there think it's a good thing now. But they're very sensible, the Swedes. Anyway, thank you for the opportunity to give the talk, and thanks to those online. Thank you.
Awesome. Thanks, Dave. If anyone does have questions online, feel free to chuck them in the chat box. Otherwise, are there any questions from the audience?
Anything from the podcast?
Anything from the podcast? So what do you think the biggest problem is, Dave? Is it the lack of risk, the lack of risk to take on deep drilling and all the other high risk activities that the miners needs to drive the future wave of discoveries? And as you said, with Barrick at Reko Diq, they're taking on the geopolitical risk of getting some of these assets into production.
Timeframes. And not that I'm getting the echo again.
I think it's you, it's external.
I need that on.
Yeah.
I need that on, actually. It's the timeframes, and it's not even necessarily the timeframes of the resource companies themselves. It's the time companies of their investors and the giant funds that own positions in them. That comment about the copper out of the Australian Financial is typical. Any analysis you read around our industry is looking 6, 12, 18 months, 2 years, heck, man, 3, 4, forget it. But that's where the financial markets look. The oil and gas guys are big enough that it doesn't matter. Right. And it should be our business to put them out of business, of course, but that was also not happening anytime soon. But they have the free cash flow right now to take over the actual minerals industry at a profit. They don't even need to do anything. They just spend their profit and buy the minerals industry, which they might do. I still actually think that's a thing.
So,
Time.
Cassie asked a question online. You mentioned the importance of ore body knowledge. What can research and educational groups like MDRU do to help ensure future geoscientists understand how to build ore body knowledge?
I think it's one of the last places on the planet actually does it, isn't it?
There's a few of us, but
Yeah.
we're getting thin on the ground.
It's so multidisciplinary, isn't it? It's so, I mean, there's ore body knowledge and ore body knowledge. Let me just go. I do this, will probably still hear me, I think.
Yep.
Yeah. Ore body knowledge doesn't make sense until you've got 3 or 4 years of geoscience training under the belt, I don't think, which is a challenge. But it could be taught. I mean, systems and all that get taught now, but then people would go, well, how, if that's a system, then maybe the question is, now you understand the system, how would you identify? You hear now? Can I hear? Yeah, okay. Yeah, that's a really good question. I say to people, I used to talk to the industry, mining industry, less than geoscience, the mining people, 20 years about it. Absolutely no one had any idea what I was talking about. 10 years ago, 5 years ago, yeah, it's actually been interesting now. We do need to know more about the ore deposits. And now it's actually very flavor of the month in the miners, not just the geoscientists, but the mining engineering departments. It's very flavor of the month. Went through old names like geomet and mine to mill optimizations, things like that. Now, I'll tell you, in the Pilbara in Australia, the scale of the operations there in the Pilbara, which are just beyond comprehension, the ore deposits that Rio and BHP are mining are dropping in grade and getting more difficult to mine as well, and they're getting more and more impurities in them. They're having this great come to Jesus moment where they're going, if we had more ore body knowledge, we would have optionality and be able to plan 2 years ahead. They don't. So there's a lot of flappery going on now when they're wondering how they can inject ore body knowledge into their short-term planning. So now that means a lot of re-drilling, right? So it's costing, and they're doing drilling in front of blast hole drilling just to get a grip on it at that level. Then they want to start doing more drilling before the pre-blast hole drilling, if you like. You also need to understand because ore body knowledge is a catch-all, right? So what's the problem? What should you know? What should you think might be a problem in the process, the plant you're designing? So it means you need to talk to the Mets. What's the design of the circuit? How are they going to process the ore? The mining engineers, the short-term planners, you've got to get as much information out of them as possible before you can determine what you need, because there's an infinite amount of things you can measure, but what's important, what makes a difference. So you need this very broad understanding of a mining operation, but it kicks right through to greenfields. Then the conversation becomes those 10 holes versus 11. Should I run downhole EM depending on the target and everything in the rocks? Should I have run downhole EM on those 10 holes and not done the 11th? Then at least I can see off those 10 holes and not have to actually drill right into something. I think you'd probably argue that you'd pay for the EM and run it down those 10 holes and things like that, the value of doing that.
Yeah, Craig, and I might repeat it for the people online.
Yeah, I agree absolutely with the emphasis on timing, and now that I've been in here for 2 years, that's really the thing that kills the box over there, which is about true negative. Right, because you can't get to a point to make a negative decision about a project until you've had enough opportunity to put that money into the ground. Because tenure is slow, permitting is slow, First Nations communities is slow, HR is slow, financing is slow. Your 5-year program is a 7-year program. So you're spending more years to keep the program alive, so you're actually putting less money into the ground to make that negative decision. So everything is just about time. And I guess I just wanted to emphasize that that's what I find absolutely what I said. But the thing I wanted to ask you about was that dramatic drop in discovery of copper rate is also equivalent to dramatic increases in exploration spending.
Yes.
Spending more money isn't going to solve this problem.
No.
So where do we go next? Like, it can't just be technology driven, because we're just saying that it's hard to actually implement technology. Slow the program down.
Yeah, I think time is an impediment. I think the other fundamental thing we grapple with is drilling, the actual process of drilling. So to prosecute something at plus 1,000 meters, we would like to, plus 1,000 meters, even in well-known surroundings, is barely touched, barely explored. I mean, geophysics from surface is just a joke at those sort of depth. And there's a hell of a lot of room to hide things. We don't have the scale of companies and budgets to prosecute those things rapidly. I know there's been a bit of chat. So with really, so I've just got the repeating my ear, but sorry. The oil and gas companies get together to share risk in, you know, really deep drilling, what they call really deep, expensive drilling. I don't think it's beyond the pale that the bigger metals companies get together and share risk with really deep technical drill programs and they're not difficult terrains. It's difficult because they're deep to prosecute. I think that might be one way things could unlock a lot of potential. We do forget that. I mean, you look at a map and see all the drill hole collars and things explored, but if you look into it, often the average depth of the drilling might be 200, 250 meters, if you're lucky, depending where around the world. But if something's at a kilometer's depth, man, that, you know, conceptually it's attractive to explore at that depth, but the technology we have just to drill at the moment just isn't there. So hence we've been working on a coil tube rig, things like that would be complete game changers in the exploration world. But again, we're not quite there yet. Just drilling, the greatest, there's no escaping it, but it is just slow and difficult. And then you wrap around the permitting and environmental legislation, etc. BHP came out just recently. What's the name of the new CEO there? Mike Henry, yeah. And he's actually been the most outspoken of the CEOs of the big mining companies. He's saying some good stuff. But he came out and said, look, the governments need to get on with the mining industry and get on this, right? They need to help us and not inhibit us, because if they keep inhibiting us, it's them that's actually will hold up all of this. And he's right, you know, rather than being combative, they should be helping. But then I was talking to someone else who was talking to him, had a beer with him last week, and he went on a global tour and he was gobsmacked as he toured around the globe at the number of countries that were willing to do anything and throw any level of money at all at BHP to come into their countries and explore. So things, the world, things are shifting. But of course, a lot of these jurisdictions, you know, don't really survive the risk analysis if you're going to go and spend some tens of $billions building something. Places where we completely undervalue this sort of activity, ironically, are places like Australia. Right? We don't spend anything to attract anyone to do anything particular anymore. Sort of used to ride on the sheep's back, now we ride on the iron ore and coal and gas backs, but don't particularly encourage anything new or novel to happen.
Yeah, maybe come back to your training comment there, Dave. One of the things I think we do poorly at UBC and probably at most universities is we immediately silo our students in first year. So students choose engineering or science basically into the first year program, they get accepted. And so there's immediate siloing that takes place in how we train people at a very, very early stage of education. I think that's a big problem.
I often wonder if, and of course, the big companies do like to complain about their graduates and how people are trained and everything. I get a bit sick of that as well. I think, well, why don't you fund like a Berkeley or something somewhere in the world, and people go there, and it's it's outside the university system, it's separate, but people from the best unis go there, gets the kind of track, and they go there for 12 months, right? And for a really you know, the best and the brightest, taught by the best and the brightest, surrounded by the best and the brightest, go for 12. And that's its purpose. And it's funded by the bloody mining companies to do that. And then it becomes the honeypot and keeps it going. That's one way I could think of doing something. But man, I mean, for young people entering the industry, despite some of these problems we're talking about, man, doing geoscience with a smattering of Python program, a little bit of maths in the background, you can be hot property for decades, honestly. You'll have great jobs, you'll be in demand. I think in the next 5 years, the community will actually get over itself, because I think this message will sink in, and you'll be sought out for people to talk to you at parties rather than being left in the corner. Yeah. It's the crazy academic in the corner.
Yeah, I think come back, you know, is there a silver lining to the Ukraine? All of a sudden, a whole lot of people realized they were pretty dependent on energy and fertilizer and a whole bunch of other things all of a sudden cost 10 times much as it did 15 months ago. And so a whole bunch of people did freak out, and our head of department at our retreat put up a beautiful image of a mine and sort of talked about it. And I said, you do realize it's a potash mine from Russia that is no longer supplying potash to the world's market. And that's why a whole bunch of people in the third world are going to die in the next 2 or 3 years, because we will not grow enough food as we pull fertilizer off the table. So the impacts have actually hit home around some of those resources. Resources, when you don't have them, resources matter. When you have them, no one cares.
Yeah, the supply chain is sexy again.
Yeah. Well, that's great. I don't think there's any more online questions. So thanks, Eddie, for joining us online today. Unfortunately, you can't come to the pub for a beer. But for those of you here, I think we're going to go across to the gallery in the next building over to have a beer, or your beverage of choice. So please come and join us. So thanks very much, everyone.